Okay. So I want you all to try to do 1 and 2 while I make sure my daughter is still here. So I'll be back. I'm going to give you 5 minutes to attempt it. You need to read this, and then you're going to do a calculation, and then you're going to write an equation. Set a timer for 5 minutes. Okay, how we doing, y'all? Turn off the timer. Let's read this together. Well, just in case you all are else. Oh, here we go. What do we got? Oh, I love it, Mike. Love it. So we got a pizza party. You're on the planning committee. We got $9 per pizza, and we're allowed a total of 175 for food, and we're going to calculate that amount, right? If I were to put units on this, I would do $9 per one pizza with a total of $175 to spend. And so if I wanted to calculate the number of pizzas I could use dimensional analysis, which might be overkill here, right? And I could write it like this, which is exactly what Mike told us. And this would get us the number of pizzas. Notice the units of dollars would cancel and we'd be left with just pizzas. Love it. So that's 175 divided by 9, which is 19.444444 forever pizzas. Obviously, that doesn't make any sense, right? We can't buy 44% of a pizza. I mean, maybe we could, I don't know. So we would round that down. Well, I shouldn't say down, we would just round 19 pizzas. Wonderful. Okay, so how did you do with the equation? We defined C, you're to define C as cost, P as the number of pizzas. And then 9 is this constant in there that is really a rate, right? Because it's $9 per one pizza. So let's see, the total cost is going to equal $9 times the number of pizzas we buy. Does that make sense? And if we were to keep the units in here, this would be 9 over 1 pizza. And this would be P pizzas, technically over 1. And these items these pizzas would cancel if we were to actually know what P was equal to, and we would be left with dollars. And that's, again, where kind of dimensional analysis can help you see if you've set up something correct or not. Okay, so here we are to complete the table, and then we're going to use it to estimate the pizzas you buy. Well, notice what we wrote above. I'll write it again. The cost, which is this column, is equal to 9 times P, where P is this column. So I'll write out the first one. That's easy, right? 9 times anything, 0 times anything is 0. And then really the rest of these are just 9 times, or just multiply the number times 9. So what, 45, 90, oh, it's the sum of those two, 135, 180, it's 2 of those, 180, plus 1 of those, 225, does that feel right? And 270, does that seem okay for you all? Put in the units in, but often we leave the units out of the table. How y'all doing with that? Maybe it would be helpful to show how I got each of those. So when P equals 0, I did C equals 9 times 0. When P is equal to 5, which is the second line, I did C equals 9 times 5. That's 45, and that's 0. This is called substitution, where we're taking our equation and we're substituting in the value for P. Dot, dot, dot. Okay. I'm just going to assume you're good. And I don't want you to draw this by hand. I want you to do this in Desmos. So we're going to take this table and we're going to type it in Desmos. That's skill I really want you to have. So let's ignore what I did in stats class. And recall that to put a table in, you click the plus sign, you click table, and away you go. 0, 5, 10, 15, 20, 25, 30. 0, 45, 90, 135, 180, 225, 270. I'm going to pause and give you a second to get that in. And let's make sure we all have essentially the same screen. I'll make this large. Y'all let me know when you've got that typed in. Okay, good. Got 3 of you with it. Would you agree that that looks very linear? Right? They're all on the same line. So let's prove it to ourselves that these two things mean exactly the same thing. Now, if Desmos prefers the letters Y and X for our variables, so what is always happening when you see a table is that X is the first column, Y is the second column. So that means if I'm going to type this C equals 9P into Desmos, I'm really going to type in Y equals 9X. So just type that, Y equals 9X, and you will see that every single point in the table falls exactly on that equation that we wrote. So the two are the exact same thing. Now, of course, our line doesn't have any meaning when X gets negative, because that means negative pizzas, and then the pizza place is paying us money, is the only like reasonable explanation of that. And that of course doesn't make sense because that's not going to happen. Okay, so let's keep moving. We've got our graph and our number of pizzas. So here our author points out that yes, we have $175 to spend, but we can't get a whole number of pizzas. We can get 19.44 pizzas. So we want to know at most how much is it going to cost us to buy the max, what's the maximum amount? Now, at most is an inequality sign. So we have $175 to spend as a maximum. That's the largest our value could be. So that cost is going to be greater than or equal to $9 per one pizza times the number of pizzas, P pizzas. This is our little inequality. Now, if I write that without its units, it probably looks a little better. It's 175 times 9p. And really, if we go back to our table, we kind of already know the answer, right? Because 175 is somewhere between 15 and 20 pizzas. We already know it's 19. The question is, what's the exact cost for those 19 pizzas? Well, we could just type 19 in, right? No, we can't type it there. We could just type here, 9 times 19, and we get our exact 171. That's somewhere sweets. Hang on. So if we were to solve this, we could get that we can buy at most 19.44. Has to be less than 19 pizzas. Again, we already knew that. Okay, how we doing? Are you all tracking, or is this getting crazy? I feel like I'm maybe going too fast or too slow. It's always hard to tell with these online faceless classes, Okay, thanks, Mike. Good. Okay, Alyssa, awesome. All right, so let's take a look at this line that we drew. The textbook's a little weird because we just toss in this inequality all of a sudden, and back here we were working with an equal sign, right? So like, what's up with that? They are slightly different in terms of what they are. Like, we could go back here and we could write an inequality. I'm doing I did shift, I did this thing on your keyboard. You can access it right here if you want to type this, and then if you put in 9x, you get this you get this picture here of the inequality, which I don't think is super useful for us. I don't know that this is worth really looking at. But that's what our author had to solve. This gets more interesting because when we talk about, hey, what is the slope of the line you drew and what does it represent? If I write this down, remember slope from 2-3, it was that rate of change. So our slope is the $9 per one pizza. And it's the price per pizza, right? It's the price per pizza. And then the y-intercept, that's that 0 value. In our case, it's 0, 0, and it's the cost of buying 0 pizzas. That should make sense, right? If we buy 0 pizzas, we have 0 cost. Oh, come on. Okay. So now the author says, well, let's complicate things. You don't want to drive to pick up these pizzas. You want the company to bring it to you for whatever reason. And so now there's a $10 delivery charge. So we're going to have to start the problem again. And we're now going to do this cost of buying pizzas with the delivery charge included. So we're going to start with this. What do we need to do to fix it? What do we need to add? What am I doing? Okay. Love it, Mike. Yeah, all we're going to do is add to the 9 pizzas that we're buying, the 9 times the pizzas, the $10 extra, and we get a new total cost. So, of course, that changes all of this, right? So now our starting value is 10, and then we're going to take each of these values up back here, each one of these, and we're just going to add $10 to it, and we've got the table filled out. So I'll go back to this table so I can look at them both at the same time, and we'll fill in that mess. So the 5 pizzas that initially cost $45, they're now $55. The $90 becomes 100, and then 145, and then 190, 235, and then 280. Okay, I'm going to come to over here, and I'm going to add this table to Desmos. So I'm going to create a second table. Notice, by the way, that the labeling of the tables are now X2, Y2 versus X1, Y1. And I'm going to type in my same X and Y stuff. And then now I'm going to change these values. And then I'm also going to type in my new equation, y equals 9x plus 10. And then we're going to take a look at our table. Check that out. Let me know when you got that all in. Okay. Notice that all we've done is shifted the original line up 10 units, right? $10. Not a super big change, but also notice that it messed with our y-intercept, but it didn't mess with our slope at all. So here we got our graph. Oh, we're supposed to estimate the solution now. Well, let's go back to our table. What we can do is get the solution exactly by typing y equals 175. That's how much we can spend. We go to our graph, so we just click the two, and you can see the $10 delivery charge reduced the number of pizzas we could buy by 1. We can buy 18 and a third pizzas versus 19 and 0.4444, right? Should make sense, right? Because a $10 increase in price, that was $1 more than the cost of a single pizza. So we should have expected it to reduce the number of pizzas we could afford by 1. Although that 44% didn't guarantee it would take it all the way down 1. All right, so we're right in solving an inequality that we can use to find the number of pizzas you can buy with the delivery charge added. Okay, fine, we'll do it. We already did it, right, graphically. So here it is, this. And I like the solution we just did, and that is where we had this graph. This was 10, we drew this. This is 175, and we did this. This was 18.33, 175. And I like that as my solution. P is approximately equal to 18.33, meaning 18 pizzas. Now, some of you might prefer an algebraic solution. And the way we would do that is we'd subtract 10 from both sides. This goes away, we get 165. That's how much we can spend on the pizzas. Divide both sides by 9. That gets us the 18.333, which we would round to 18 because we can only have a whole number of pizzas that we purchase. So our author is going to ask us those same questions. Hey, what's the slope? Same thing. It's the $9 per one pizza. And it's the price per pizza, or cost per one pizza. Happens to be a unit rate. The y-intercept is 0.10. And this one doesn't make any sense, right? Because it's the cost of buying 0 pizzas. And of course, the pizza place is not going to charge us to buy 0 pizzas to delivery, because they're not going to drive up to your place with 0 pizzas and say, where's my $10, right? You have to buy pizzas to be charged the $10. But algebraically, this is what it is. This is what it means. It might be worth saying, in context, this is not useful information. In context, the y-intercept does not make sense. This is often going to be the case. Doesn't mean our model is bad. It just means we can't use the y-intercept for interpretation. Now, I am assuming you all are good at identifying what we mean by the slope and the y-intercept. Slope meaning a rate. Y-intercept meaning an ordered pair 0, b. So I'm making this assumption from what we did in 2.3, but maybe I shouldn't. Is everyone okay with how I'm just quickly saying, hey, this is the slope, this is the y-intercept? Oh, John, you did it. The author wants us to put this all together. Okay, Mike, awesome, good. And we're going to put together what's called the slope intercept form of a line. So here's a little bit of language that's used a lot in algebra courses. Coefficients are the numbers in a term. So the coefficient in this term is 9. The coefficient in this term is 10. When the term is just a number, a term that does not have a variable that you can see, we call it a constant term. So this 10 is really the constant term. And we just leave it at that. And then this 9 is the coefficient of the 9x term. What we've put together here is the slope-intercept form of a line where the b comes from the y-intercept, the 0, y-intercept part. It's the constant term. By the way, the author points out that it doesn't matter the order you write these. It could be y equals b plus mx, which is not how it's taught in high schools, or y equals mx plus b. Either way, they mean the same thing. Of course, the reason is 2 plus 3 is the same thing as 3 plus 2. They both equal 5. So it doesn't matter the order you add things, you get the same results. It does make things look different on a page, of course, but the results themselves are exactly the same. So our job now is to start reading problems and looking for the m's and the b's. So if I were to generalize that, instead of saying slope, I might say m is a rate of change and b is an initial value. It's a starting value. Whether it's time 0 or whatever. So I want you to test this on number 15. See if you can't write the equation for that. I'll give you 2 minutes. Set a timer for 2 minutes. Anyone got the equation?
I got y equals 4x plus 12.
Nailed it, Mike. Yeah, I love it. Crushing it. So if you read carefully, if anyone didn't get that, note it says, and a small business had just 12 employees when they opened the doors, meaning this is an initial value. They started with 12. Then they have been adding employees at the, wow, we were super nice to you, rate, awful sound, rate of 4, keyword for any rate per month. So if I were to write out, if I were to label everything here, Y would be total employees, X would represent months, 4 is the rate of employees per 1 month, And then the 12 is the initial employees. So what's the slope? I guess we said that. Y equals 4. What's the y-intercept? 0, 12. What do they tell us about the company? Initial amount of employees. And then this is the linear growth rate. So let's draw our graph. Again, don't ever do anything by hand if you can help it. That was y equals 4x plus 12. Now, the graph I have is, the view screen I have is probably not the best. If I click the home button, it gets us back here. Again, maybe not the greatest. So I'm going to hide all this other stuff that I have. And there's our graph of with our y-intercept of 0, 12 and our growth rate of 4 employees per 1 month. It's what I'm interested in for this class is your ability to do stuff graphically, or to do it with technology, not by hand. So what I would do is have this, and then if we needed to write it on a piece of paper, I would just do something like, I don't know, let's call this 12, 16, 20, and just be like, yeah, there's my graph. Wonderful, isn't it beautiful? What is important, though, is your ability to label the axes and understand what each one means. Months and employees. That is important because that's the context of our graph. Okay, so I don't care that you can graph things by hand at all. This is what this is all about. Just know how to type it in Desmos. Ignore this, just type it in Desmos. So like this one, y equals -10/3 x plus 12. You're just going to come over here and type y equals -10 divided by 3 times x plus 12, and there's your graph. Right? Why bother doing that by hand? We did that. Just as long as you can type, you can get your perfect graphs. So let's move on to the blood alcohol content, but I want to pause and make sure there's no questions. Are there any questions? Okay, so let's look at, let's read our prompt here. So blood alcohol concentration is a percentage of alcohol in the bloodstream. So these numbers are given as percentages. I believe these come from, this is from, it's from WebMD. This is where our author got these things. They're pretty commonly understood numbers. So this is not 2%, it's 0.02%. If 2% of your blood was alcohol, you would have been dead for a long time, right? Look, they're saying if 0.5% or more of your blood is alcohol, you are not alive anymore. I don't think I could tell you the reasons. I mean, blood is what gets oxygen throughout the body, all kinds of different stuff. I don't know all that very well. Maybe you all know it better. But obviously, you don't want lots of blood in your alcohol, or alcohol in your blood. I don't think you want blood in your alcohol either. But I mean, it's what flavors meat, right? So maybe you would want blood in your alcohol. I don't know. At any rate, so the legal limit for driving a car in most states, I believe this is true in Michigan, is 0.08, meaning 0.8% of your blood can be alcohol. Which is interesting, right? If you think about that in terms of driving in accidents, like if you look at the observable effects between these two, and these are generalized across all humans. So, some people can have more a higher percentage and maybe not have quite as much of these observable effects. But we're getting to the point of sedation and slowed reaction time, which is the problem with driving. So someone hits their brakes and it takes you an extra second longer to hit your brakes, and there you crash, kind of thing. So I believe, does this mean that if you're at 0.08%, you're not in trouble? The legal limit, or does it have to be under that? I don't know. I guess we could look it up. Okay, so we're going to use this scale to interpret our results, to interpret stuff. So apparently when this author wrote this thing, some Hollywood starlet had 3.5 times the legal limit of alcohol in her blood. I think he's referring to Lindsay Lohan. I think that happened to her, but it could be. I mean, even didn't Tiger Woods recently have an accident? Maybe it wasn't from alcohol. Maybe it was something else. But there's lots of people have made the unfortunate choice of driving under the influence, and bad things happen. Well, if we're going 3.5 times, 3.5 is the same thing as 3.5. Here is the legal limit. So we just want to figure out, what is that? 3.5 times 0.08, 0.28% of this particular person, their blood. So what does this mean? Well, we would go back up here and we'd say, oh my, they're in between these two. So they're almost to the point of passing out, having memory loss, their body temperature is cooled down. They're in between, they're straddling this line of observable effects. So they were unfit to drive, clearly. So they might have been the double vision, et cetera, et cetera. Oh, I guess exactly what we're saying is 0.28% of her blood was alcohol. So here's some of the effects of it down here, right? That's what I was listing there. So yeah, good thing she got pulled over and arrested so that she didn't kill herself or someone else. I think usually I think statistically speaking, the person who is drunk in a car accident usually has the less severe consequences from the accident because their body is relaxed. Have you all heard that? Like when you get in a crash, you tense up, and that can cause more damage to you than if you remain relaxed. All right, so we're going to do a nice little problem here. We've got Mr. Bonehead. Our author likes to make jokes. Decides it'd be a good idea to drive when he shouldn't. He gets pulled over before anything tragic happens. Good. Gets a blood alcohol test at a level of 0.26 at 2 a.m. And then we're given a piece of information here. And that is that studies show that alcohol leaves the bloodstream at a constant rate. What does that mean for us? What does it mean for a constant rate, mathematically speaking? Nailed it, Mike. That's it. Linear. And it's a linear, and that constant rate is the slope. It's the rate of change. So the blood alcohol content, the percent of your blood that's alcohol, leaves at a constant percentage over time. So here is our thing. Remember from 2.3, we could calculate slope using a formula. So if this is indeed constant, we just need to find the difference between any 2 points. So let's do that. I'm just going to pick the first two because they're nice. Maybe they're simpler numbers. So I'm going to do 0.145 minus 0.16 divided by 1 minus 0. Yeah. So that rate, a constant rate of change means that rate of change is the same. That's awesome for each. And I think we're assuming here hour. So 0.145 minus 0.16 equals, divided by 1 is that. Now let's pause and talk to ourselves. What does this mean? What is this slope telling us? By the way, if we were to put the units on it, it would be blood alcohol concentration per 1 hour. Can anyone interpret that slope? I think the main thing I'm concerned about is anyone bothered by this negative? So what this is telling us is that the blood alcohol concentration decreases by 0.015% per hour after you stopped consuming that alcohol. Which is a way, like if you were someone that was interested in drinking at a party and then wanted to know when could you drive home, you can do some calculations. I'll show you this. It's an interesting place. If you go to Wolfram Alpha, oops, there we go, Wolfram Alpha, and you go in here, how drunk am I? What research has shown is that the blood alcohol concentration is based off of how much you drink, number one, how much time has passed, number two, which they're using a linear equation, and then your body weight, as well as male versus female. And this is based on like the composition of your body, how much muscle mass do you have versus the other part. And so if you put in here, and well, then the other thing you have to look at is what's the definition of a drink? I remember in one of my college health classes, a drink was one 8-ounce can of beer, I forget what the glass of wine was, and then like a shot of some kind of hard liquor. And you put this all in and compute it, and then it says, this is your blood alcohol percentage, so you're fine for driving home if you've had 2 drinks in 1 hour. Again, like I said, you would need to know what is that defined as. If you had 8 drinks in 1 hour as a male weighing 140 pounds, you're at the 0.3% alcohol, so you can't drive for 11 hours. Plus, if you think back at the observable effects of this, you are getting in a pretty dangerous level of alcohol consumption. Okay, I don't know what that aside was all about. So what's our y-intercept? Remember, y-intercept is always the x coordinate is 0. What's the y coordinate? So 0, 0.16. What this means, it's the initial blood alcohol content after you stop drinking. So after John stopped drinking. Okay, so we're going to write an equation here. Note, we know the slope here, our m, that's this number. We know our y-intercept, and the b coordinate of that, that's this number. So our equation is just y equals mx plus b, where we need to fill in the number that gets multiplied times x plus the number we're adding to it. In other words, the slope, which is negative 0.015, and the y-intercept, which is 0.16. Now we've got our equation, and we can model all kinds of stuff with this. So we're going to use our equation. We're going to restate your answer question 6 and form a statement like this. If x represents blank, then y represents blank. Right? So, boy, x here is hours after 2 a.m. Y is the blood alcohol content. So x is the hours after 2 a.m. and y is the BAC. Let's write it this way. Y is the BAC. Oh, I don't know why I'm erasing this. Y is the blood alcohol content at that particular time. At X hours after 2 a.m. So let's go ahead and graph this equation. So we're going to go to Desmos and we're going to type this thing in, and then we'll look at number 8 and see what's going on with that. And the cool thing about the graphs is it gives us all the information. Now I'm going to just start over with a new blank graph. And here I've got y equals negative 0.015x plus 0.16. There's my graph. I'm going to do something interesting here. I'm going to copy it. So I have 2 of the same. The way I did that is I click this edit, and there's this copy button. I'm going to click this gear button again, and I want to turn one of these into a table. So convert it to a table, and it just quickly fills in a bunch of the points. And then I'm going to click the zoom fit button, and we'll get this nice view of what's happening. Now, I'm also going to label my axes here. So I'm clicking this, what is this, a wrench thing here. And for the x-axis, I'm going to type in hours. For the y-axis, I'm going to type in BAC. I'm going to click this big A button to make it big. And we don't care about values before 0. We don't care about negative values. That's when he's still drinking. They don't really make sense. So really, we just want 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. And you can see that what's happening is we're getting to the point, or we're seeing how much blood is in, or how much alcohol is in the blood, the percentage of it over time, and you can see where it's going to be 0, based on the theory of how alcohol is processed in the body, that it leaves at a constant rate. And for this particular individual, it left at 0.015% per hour. Remember that this kind of thing is based on your body, your particular body makeup. So while it's constant for all people, the constant rate it leaves your body is not the same for everyone, which probably goes without saying, but it's worth saying it. So for our guy, it's going to take him approximately 11 hours for there to be no blood or no alcohol in his blood. Now, oh, wrong one. So now we're supposed to answer a couple questions. Now, I like that our author says this, because sometimes people think, well, maybe if I drink a cup of coffee, that'll help sober me up, or I'll eat some food and that'll help sober me up. And the reality is none of that has any effect on the percent of alcohol in your blood. It doesn't speed it up or slow it down. So the first thing we have to do is figure out what is the X value for this 3:30 a.m. In other words, if time 0, so X equals 0 corresponds to 2 a.m., what X value should we use for 3:30 a.m.? What do you all think? Getting bored. Oh, nice little bracelet. Well, I know that it takes 1.5 hours to get from 2 a.m. to 3:30 a.m. So that means the X I'm going to use here is 1.5. That's the amount of time that's passed between the two. So what we'll do in Desmos, we can do it 2 ways. We can type 1.5 into our table. And there's our magic number, 0.1375. Or we could do the calculation. We could do or type it into our equation, negative 0.15 times 1.5 plus the 0.16. Either way, we get the same thing. And the blood alcohol percentage there is 0.1375 at 3:30 a.m. 0.1375%. What we could ask ourselves is, hey, can Mr. John go driving yet? Of course, the answer is no, because he's not below 0.08. We can also say he's got poor coordination. His thought processes have been slowed down. His speech is slurred at this point. So definitely not safe to drive. And also not legal to drive. And then we're set, how many hours would it take for his BAC to drop below the legal limit of 0.08? And again, the author is trying to dispel some things that college students like to talk about, and that is cold showers will help wake you up. No. So this is a Y value. So we're going to take our equation, y equals negative 0.015x plus 0.16, and we're going to replace this Y value with that 0.08. And then we could solve this algebraically. Subtract the 0.16, divide by negative 0.015. Of course, our author says to solve this as an inequality, but to me, I would say just solve with the equal sign, and then we know it's anything any time below that or any time past that. But there's a super nice way to solve this in Desmos. That is, we've got this side is one equation. So y equals that. And then this side could be another equation, y equals 0.08. If we graph those two things, y equals 0.08, then we will find where those two intersect. Now, I'm not interested in the table because it doesn't work, but where this line is, that's going to be the solution. 5.33 hours is the point where he's finally legally able to drive, although I would argue probably still shouldn't. Why risk it, right? So that solution, X has to be a number larger than or equal to 5.3 hours. How y'all doing? I feel like we should solve this algebraically, just for those of you who like that, just so you can see it. And there's one little thing you have to keep track of with inequalities when solving, and that is what happens when you divide or multiply by a negative. So here I'm going to subtract the 0.16. Our goal is to get this X term by itself. So all that goes away, and I'm left with a negative 0.08. I'm sorry, that color is off. Let's get dark green. That's going to be less than or equal to negative 0.015x. Here, we need to undo the multiplication. So I'm going to divide both sides by that 0.015, that negative. At this point, because I divided by a negative number, we've got to switch this inequality for it to make sense. So x needs to be greater than or equal to whatever that number is, and it turned out that was 5.33 hours. I am perfectly happy for you to solve any equation that we work with using the graphical method I showed you here in Desmos. In fact, when we get to exponential equations, it's really going to be the only way I teach you, because I'm not going to teach you logarithms, which is what we would need to solve an exponential equation. So you do need to understand how to do this. You just don't have to do it yet if you are happy with the algebraic method. Okay, what do we need to draw the graph? The equation, that's all we need. We've already graphed it. It's been graphed for hours. Ooh, what is the x-intercept? Okay, so that's a great question. I clicked it here once before, right? The x-intercept is where it crosses the x-axis. And so we're seeing that's 10.66667 or, 10.7, whatever. The way we write x-intercepts is like this. I'll put the line over the top to show that. And this is what this is telling us is the number of hours until the BAC is 0. And that's 0%. That's after, of course, 2 a.m. So maybe if I was to get that super correct, I would say, come on now, number of hours after 2 a.m. until the BAC is 0%. Okay. I think this is important to note. Here's a line with a positive slope. That was the pizza line. Yeah, we get a pizza problem. Here's the line with a negative slope. That's the blood alcohol one we just did. And then a line with a 0 slope. The 0 slope line is the one we use to solve the equation graphically. And that is, it's called a horizontal line. I did a bad job drawing it there, but that's a horizontal line, which means 0 slope. There is no vertical change. There is one other option here, and that is if there's no change in the y. That's this vertical line. This is an undefined slope. And that's when you have, like, if I use the slope formula, you've got this divided by 0, no change in x. That's undefined, but we don't use that because there's not a lot of, well, we will use this to solve things graphically. It is kind of helpful. Okay, let's make sure we do the lesson check for today. This is the 2-4 section. Am I in the right class? No, that's my stats class. Where are you? Where are you? So here we go, 2-4 lesson check. Oh, come on. No, don't get this wrong, you won't be able to redo it. What is the slope? Question 16. So it's the first set of questions back with the pizza stuff. It's going to be the 9, I believe. Am I right on that? Maybe not. Here we go. Oh no, the slope is 4. So this is the 2.4 lesson check. What is the slope of this line? It is the number 4. Technically, it's $4 per pizza, but apparently Canvas doesn't like units. Hooray! Okay, what questions do you all have about what you've just seen? The good or bad news is that really the worksheets and the course pack do not align with what we've just covered. So there really aren't any worksheets we can do yet because we need to get through 2.5 to learn the technology we need in order to do what you're asked to do in the 2.5 worksheet. So if you look at the 2.3 worksheet, okay, so if you look at the 2.3 worksheet, you can see problems like what we just did, the second 2.3 worksheet. So here, number 4 on page 23, you're graphing this and you're going to note what kind of slope it is, whether it's positive or negative, and if that makes any sense. And number 5 is the question we just did. Here's a car you purchased for this much, unfortunately loses value, it decreases by $100 per year. Hey, what's the y-intercept and slope? Hey, can you write the equation? Hey, can you graph it? And then the 2.4 worksheet, you can't do it all because it talks about line of best fit, which we're not going to study until 2.5. So really the 2.4 worksheet and this 2.5 worksheet we'll look at after class or during class on Wednesday. Have we talked about the project too? Have we all looked at that? Do you all kind of know what's going on? I think we previewed that, didn't we? We're really not ready to do much with project 2 yet because it's all a modeling project. Once we get through 2.5, I think we'll come back and talk about this a little bit. You could look at task 3 though, and you could do task 3. So that's one thing you could start with. And that is, I'm giving you a rate. I'm giving you some other information where you're creating a table. You're going to create a table, a scatter plot. You're going to write the model. You can tell me what type of model it is. And then you're going to do a calculation and explain some things. Note, we're asking you to use your information from your first task. All right, so just copy in your weight or the calculated value from project 1, task 4. Okay, I think we've done what I would have liked to accomplish today. I'm just curious where you all are at. What do you need help with? What do you all need to be successful in this class? I think I'm even going to stop recording.